Hey guys, this is Amitesh, and today we'll be talking about interstellar travel, or the travel to the other stars. Traveling to the other stars and planets is perhaps mankind's greatest dream. Has any technology captured the world's imagination as much as the space travel? We didn't reach the moon until 1969. Before 1992, we knew of no planets outside our solar system. Nothing made by the man has ever visited another star. Yet so many books, movies, television shows, and video games revolve around the idea of men traveling to the other stars. We are fascinated by it. The question is, can we ever make this dream a reality? Astronomers have now discovered thousands of planets outside the solar system. Our galaxy alone probably contains hundreds of billions of them. A recent study concluded that the Milky Way contains 8.8 billion Earth-sized planets that orbit stars at a distance that allowed them to support life. How long before we get to them? Well, space is incredibly huge, and we have made virtually no progress towards fulfilling our dream of zooming around the stars. Depending upon your perspective, this is either fairly depressing or incredibly inspiring. In most sci-fi stories, starships zip around the galaxies at speeds far exceeding that of light, universal speed limit of roughly 3 lakh kilometers per second. The problem, however, is that the laws of the physics state that absolutely nothing in the universe can travel faster than the speed of light. This is the ultimate universal speed limit of the universe. We know our star simply as the Sun. The Sun is a star, no different than the billions of other stars in the Milky Way galaxy. To provide some important figures for reference, the Sun lies 93 million miles or 150,000 kilometers away from the Sun, and it takes light 8 minutes and 20 seconds to reach us. The nearest star to Earth, other than the Sun, is Proxima Centauri of the Alpha Centauri triple star system. It lies 4.24 light years away, meaning that it takes 4.24 years for even the light to reach to us. The fastest speed achieved by the mankind was that of the New Horizons robotic spacecraft, which was launched at 36,373 miles per hour on its mission to the dwarf planet Pluto. The fastest man-made object is currently the Helios 2 solar space probe, traveling at 157,100 miles per hour. This speed was achieved by using gravitational assistance from the Sun. If Helios 2 solar probe were to be sent directly towards Proxima Centauri, it would reach the star in approximately 18,000 years. But can we go faster? For our fiction and science fiction dreams to ever become reality, we will have to go much faster than 38,000 miles an hour. Is that possible with current technology? Actually, it is. The nuclear-launched manhole cover gives us a clue how. We have reached the limits of what is possible with the chemical rockets, but we could continue and knock it up a level above with the nuclear power. The earliest and perhaps the most insane idea for a nuclear-powered rocket was quite simple. During the 1950s and 60s, the General Atomics designed a so crazy it just might work nuclear-powered rocket called Project Orion. The rocket, fitted with heavy-duty shielding, would simply keep throwing nuclear bombs at the back and ride the blast waves forward. By exploding one nuclear bomb every second, the rocket would accelerate to incredible speeds, around 20 million miles an hour. That's 500 times faster than the Voyager. But there were drawbacks. It would take detonating 800 nuclear bombs to just get into the orbit of the Earth. But this was seriously considered a viable way to launch a manned mission to the Jupiter and the Saturn. It was ultimately cancelled since NASA had to focus on reaching the moon by the end of the 1960s. However, if the Orion ship were constructed, traveling at 20 million miles per hour would just take 130 years to reach the nearest star. At the end of its journey, the rocket would have no way to slow down. After over a century of waiting, it would zoom through the star in just a matter of days. But nuclear propulsion is not the only way. One elegant solution is for the spaceship to leave the propulsion system behind. High-powered lasers in space could focus on a ship with a very large sail. With enough power, these lasers could push the ship forward. The Japanese space mission, or the JAXA, is doing incredible research in the field of solar sail propulsion. But we are talking a lot of power. Space-based lasers consuming the equivalent of all the electricity currently generated by the human race. And it would have to be a big sail, too close to the size of the Poland. Even then, the mission would take decades, not the hours or the minutes we see in science fiction. But how about traveling faster than light? Here I introduce you to faster than light travel. Nothing can travel faster than light as dictated by Einstein's theories on relativity. Roughly 186,000 miles per second is the absolute speed limit. If practical interstellar travel is ever to become a possibility, we need to find a way around the speed limit. To get around the FTL issue, sci-fi shows or movies often use things like warp drives that are capable of warping space-time in such a way that it folds space. If this was possible, it would effectively enable FTL travel between 2 points. The Alcubierre warp drive, proposed in 1994, is the only serious attempt at theorizing a spaceship which travels faster than light. It does this by expanding space behind it and contracting the space before it. The spacecraft travels in its own bubble at speeds slower than light. But to the outside world, it would be traveling many times the speed of the light. But the Alcubierre warp drive is highly theoretical and has one deal-breaking flaw. It requires something called the exotic matter with negative mass, and this isn't even known to exist. So far, we have merely discussed the propulsion system. We also have to overcome a host of other engineering problems. For example, our fast-moving interstellar ship would need a heavy shielding to prevent more space dust from puncturing its hull. And we haven't even touched the logistics involved in a space manned mission. Other solutions to the problem can be wormholes, or a bridge between 2 points in space-time that connects them together. How it works is by bending space-time itself. Imagine a piece of paper with a point marked at each end. The shortest distance between the 2 points is just a straight line, unless you fold the paper in half so that the 2 points meet each other directly. These wormholes in theory could even enable us to travel in time. But there is a downside. The wormholes are incredibly unstable and very tiny. And even if we somehow manage to enlarge them and try to sneak through them, they would collapse the next moment and destroy your ship, including you, completely. To stabilize them, again we require negative energy, something we haven't found in the universe yet. So Alcubierre warp drive is thousands of years away. So does that mean the interstellar travel is just a distant dream for mankind? Our galaxy itself contains, very roughly, 300 billion stars. The universe holds an estimated 1 septillion stars. That's over 140 trillion stars for each person on the planet today. So the possibilities of exploration are endless. In the last 2 lakh years that humans and modern humans have been on Earth, we have moved on from stones and rocks to cars, airplanes, spaceships and space satellites, traveled to the moon and sent probes to the Jupiter, Saturn, Venus and Mars. And mind you, 2 lakh years is just a blink of an eye in the cosmological scale. Our Earth still got about 2 billion years or 10,000 times more than what we have been on this planet. So we have got plenty of time. What we need is a spark of imagination and the curiosity which have empowered us to travel to the uncharted territories. Thanks for watching, and I will see you next week with a very new video. Share and subscribe the video if you like it. Thanks guys.